Hi everyone! In this video, we will graph a linear inequality. Graph the linear inequality 6x plus 3y is less than 12. To graph this, we need it to be in slope-intercept form or slope inequality form so that we have y, and then in this case we have a less than or greater than sign of mx plus b so that we can graph the boundary line first. So let's go ahead and solve for y. We'll do that by subtracting 6x from both sides, giving us 3y is less than negative 6x plus 12. And then to continue solving, we'll divide by 3. So we get y is less than negative 6 divided by 3 is negative 2, and we still have the x. And 12 divided by 3 is positive 4. So now that we've rewritten this in slope-intercept form, we can go ahead and graph the boundary line. We have a slope of negative 2 and a y-intercept at positive 4. We'll start at the origin and moving up to positive 4, 1, 2, 3, 4. This is where our y-intercept of the inequality will pass. And then from here we need to do our slope of negative 2. Slope is rise over run, so we need to, let's make that into a fraction. Negative 2 can be written as a fraction by putting it over a 1, which gives us rise over run. So from our positive 4, we will rise negative 2. That means we need to move down 2. But the 1 is positive, so we'll go 1 to the right. We could also change that around and do a positive 2 divided by a negative 1. That means that I would rise 2 and then go backwards, negative 1, and you'll see that they all end up on the same line. We could have also continued from our second point going down and gone again down 2 and to the right 1. We could continue doing that as often as we want, but 3 points is sufficient to draw a line. Let's go ahead and draw our boundary line. Because we have a lesser than sign, this means that it is a dotted line. If it was lesser than or equal to, it would be a solid boundary line. And so we'll fill this in with a dashed boundary line, trying to make it as straight as possible. And there's our boundary line going in infinity in both directions. But now we need to know where we shade. So let's go ahead and find a test point, any test point we like. And my preference is always to use the origin because then we substitute 0, 0 in for x and y. We can either use the original equation or the one that we solved for y. I'm going to go ahead and use the one that we solved for y. So we substitute 0 in for y is less than negative 2, substituting 0 in for x, plus 4. Negative 2 times 0 is 0, plus 4 is positive 4. And then we ask ourselves, is 0 less than 4? Yes, 0 is less than 4. This is a true statement. That means that our test point of 0, 0 is included in all of the solutions that we will have for our inequality. This means that I need to shade to include that test point. If my inequality had come out as not true, then I would not shade where it is because it would not be a part of the solution. Because it is a part of the solution, I am going to shade in the direction that has it over here. Another way to always test is if I have solved this for the y equals mx plus b form, as we did, then I can look at the inequality and see that it is below the line. It's a lesser than sign, so we shade below. This only works as a way to verify if it is solved for the slope-intercept form. If I had a greater than sign, so if this was y is greater than negative 2x plus 4, I would shade above the line. In this case, I have lesser than, so I'm shading below it. And now we've graphed our inequality and we're all done.